Hello everyone, and welcome to the Hawks A+ Network. On this network we help students get better at math, science, history, and social studies. And this particular video is helping students get better at solving equations using square roots. Now, before we begin, I need to let you know that you need to have a book as a reference, and that book is this one right here. This book is the McDougall-Littell Algebra 2 book. From this book we're going to get all of the examples and we're going to help you get better at Algebra 2. So let's begin now. To begin, we have to turn our books to page 266, and we're going to be talking about solve quadratic equations by finding the square roots. Now, in the middle of the page, on page 266, we talk about the product property and also the quotient property of square roots. Before we can actually start solving quadratic functions using these square roots, we have to review a little bit on the square roots themselves. So let's look at the product property. The product property says that if I take a number and it's multiplied by itself, two numbers here, I can take the square root of A times the square root of B and still come up to be the same answer. Now, to take our case in point, we're going to take the square root of 36. The square root of 36 can actually be broken down into two numbers, the square root of 4 times the square root of 9. Now you know for a fact the square root of 36 is going to be 6. So let's see if it works out if we do it separately. The square root of 4 is going to be 2. And the square root of 9 is going to be 3. So when we multiply 2 times 3, we get 6. That's how come the product property works. Now let's look at the quotient property. The quotient property says that if I take the square root of A divided by the square root of B, I can take the square root of A divided by the square root of B separately. Well, let's see if that actually is true. We'll take the same numbers, 9 divided by 4. So we have the square root of 9 divided by the square root of 4, like this. And you can take it separately, which is the square root of 9 divided by the square root of 4, which means it's going to be 3/2. That's what the quotient rule is talking about. Using these rules, what we're going to do now is do example number 1. Example number 1 on page 266 says we're going to simplify some expressions. So the first one we're going to simplify in our example number 1 is letter A, which says the square root of 80. Now the square root of 80 can be broken up into a perfect square times 5. That perfect square is this. This is our product rule. I can take 80 and take the square root of 16. Now why 16? Because that's a perfect square. I can actually find the square root of 16 times another number. Well, 16 times what gives me 80? 5. So that means I can take the square root of 16 times the square root of 5 and come up with an answer. Well, this one right here is a perfect square, so I can take the square root of that. I can't take the square root of 5. So what that does is that leaves me with the square root of 5 still in the radical. And this is called a radical symbol. So that means our answer will be 4 square root of 5. And you leave it like that. Now if we had a calculator, you'd be able to find out what that is. But for all intentional purposes, all you have to do is just leave it as 4 square root of 5. Now remember where our square root of 5 is located between. It's between 2 and 3. So roughly the answer would be 8 point something. That's what we're looking for. Okay, now looking at the next one, which is our letter B. Our letter B says this: square root of 6 times the square root of 21. Now it looks like it's been separate already. So we're going to use the product rule to bring them together so we can actually multiply 21 times 6. 21 times 6 comes out to be this. 21 times 6 is 6 and 12. Yeah, it's 126. So we're taking the square root of 126. Now if you look in the book, they actually break it down into two numbers, 9 and 14. And the reason why they break it down to 9 and 14 is because 9, you can take the square root of it. So we're trying to find perfect squares in the numbers that we're multiplying by. So we have the square root of 9 times the square root of 14. The square root of 14, you can't go any further with it. 7 and 2, those are the only two factors for 14, and 14 and 1. So you can't find any more perfect squares other than the ones that are already found. So you take the square root of 9, which is a 3. And since you can't do anything with the square root of 14, the answer will be 3 square root of 14. And that's A and B. So let's look at C and D. All right, now C and D is talking about the quotient rule. So we're going to take letter C, which is the square root of 4 over 81. Now, if you know anything about perfect squares, 81 has a perfect square in 9 squared. 4 has a perfect square in 2 squared. So what we can do is we can separate these to the square root of 4 over the square root of 81. Since I know 2 to the second power is 4 and 9 to the second power is an 81, I can break these two down into their simplest forms, which is 2 over 9. And there's your answer for C. Now, how about the next one, letter D? Letter D is very similar to that one, which says the square root of 7 over 16. Now, in this case, you can't do anything with the 7. So what you're going to do is when you separate it, which is the square root of 7 over the square root of 16, the only one you can work is the bottom part, the denominator. So the answer comes out to 4 and square root of 7. So there's your result, the square root of 7 over 4. By the way, there's a rule that you need to remember. One very important rule is that you cannot have the radical at the bottom part of the fraction. So in the coming examples, you're going to have to realize that the square root at the bottom must be moved to the top somehow. You cannot, I repeat, you cannot have a radical as a denominator. So you have to fix it, and I'll show you how to do that. Here comes example number 2. Now remember, you cannot have a radical as a denominator. So we got to fix letter A in example number 2 because there's a problem. We have the square root of 5 over 2. And when you separate these two, it's going to come out to the square root of 5 over the square root of 2. It's impossible to have that square root of 2 down at the bottom of the fraction. So we have to fix this somehow. So what we're going to do is we're going to multiply it by a 1. We're going to rationalize the square root. So that means we have to take what it's being divided by and multiply it over itself. That means it's going to be radical 2 over radical 2. And what this does is this keeps it consistent because it's a 1. If I was to take the square root of 2 divided by the square root of 2, it's a 1. So I'm not really multiplying a foreign number to our fraction. What we're doing is we're actually making it possible for us to get rid of that square root at the bottom. We're making it look a little bit different without having the radical at the bottom of the fraction. So we're going to have the square root of 2 times the square root of 2, which comes out to the square root of 4 at the bottom. What that does at the top is I multiply the square root of 5 times the square root of 2, which is the square root of 10. And so now I can take the square root of 4, which is a 2, and at the top it's the square root of 10, and I can't break it down anymore because the factors for 10 is 2 and 5, and 10 and 1. There are no perfect squares in that. So what that does is that eliminates the square root at the bottom, makes the numerator a little bit bigger. But if you were to take the calculator and divide those two, it would come up to be the same answer. So what we did was we rationalized